Thank you very much for joining me today. All right, I'm going to talk about OpenCore platform product management. It just occurred to me that might be worth defining that, in case you guys are not familiar. OpenCore is really a philosophy, I think, as you've probably read in the abstract, of shipping software that has open source components within it, but other components are developed around that that are proprietary, offered in either a free product or a commercially licensed product. And it's a philosophy that a lot of enterprise software vendors are using today, and I'll sort of try to help explain why that is and what are some of the patterns that we see both in the vendor behavior as well as the user behavior that drive this strategy to be kind of one of the most commonly used one these days. But first, a bit of backdrop and real quick, a word about me. So I, in contrast to a lot of the other speakers here today, I'm going to have to learn to do multiple clicks. I'm not a consumer guy at all or a person at all. I have all of my experience in enterprise software and more specifically in sort of infrastructure platforms that people build applications on top of. So I speak a little bit different language than maybe some of the other presenters here, which I think will make a also interesting contrast in the panel discussion that we're going to have afterwards. So those are some companies that I've worked for, and maybe I just have to be closer. Train this. Played a bunch of different roles, sales engineering, so I was in the fields talking to customers, building prototypes, demos for them. Also the jack of all trades at a couple startups, very early employee at a big data company called Datamere, and then moved into being a product owner, starting my career out in product that way, doing agile product development in the trenches with the team, and then moving more into product strategy that I do here at Cloudera. I'm a Hadoop geezer. That's an American expression for a really, really old guy. And in the Hadoop ecosystem, actually, that's relatively early days. It's like the Neolithic, Paleolithic period compared to today. So I'm always trying to relive the days of 2011. What I do now is what we call core platform product management, although ironically that has very little to do with the actual core, which is more of what I'll be talking about today. I actually work on a lot of our proprietary components in the Cloudera stack, including our cluster management and backup, also platform support and a few other areas of the stack. Been doing that for a few years. What we do is we ship a modern data platform, we like to say, for machine learning and analytics optimized for the cloud, and I added an extra S there because more commonly these days we have customers who are trying to deploy our software across multiple clouds. We also do a fair amount of hybrid cloud as they expand their existing on-premises deployments into the cloud. And actually a lot of our value is around enabling that hybrid deployment and enabling the portability of moving various types of data-centric workloads across clouds so you don't get locked into any one cloud provider like Amazon, Azure, Google, and so forth as they stand up these data services, the house offerings of a data warehouse or a data science platform, a data engineering platform, an operational database. So we pride ourselves on being this multi-function platform with a lot of common attributes and a common experience, like you like to call it, shared data experience, regardless of where you deploy. And we, of course, find that customers get a lot of value when they take this data lake approach and they land all their data in one place and they can apply a variety of workloads as the business needs demand those workloads to be applied to deliver some capability to the organization, be more competitive, connect better with customers, deliver data-driven products, wherever it might be. So that's what we do. As a company, what are we going to talk about now? We're going to talk about the philosophy of OpenCore product management. I'll talk briefly about the landscape of open source. OSS would be open source software usage and the vendors and kind of what's going on there as a backdrop. And then what are some of the evolutionary models that we've learned about in our journey and I've learned about in my journey for both the usage of and the production of OpenCore products. Then we'll talk a little bit about the mechanics of operating an OpenCore product development lifecycle, and then some of the strategy questions, things that have worked well for us in our journey and might be useful to others, and then what are some of the end games as these technologies become very mature and the adoption of them becomes mature and the vendor landscape becomes mature and people start moving on to other areas. So real quick, the landscape, I'd say in enterprise software, open source eats closed source, but not for breakfast. And the reason why is because it takes quite a while for these open source options in various categories, operating system, database, middleware. It tends to happen in infrastructure technologies primarily, more so than the higher level end user facing applications. It takes a long time for them to overtake their proprietary counterparts. So the tradition has been that proprietary software is introduced and then it gets commoditized over time and open source becomes the predominant way of deploying it. It's flipping around a little bit now. Open source is kind of leading the charge quite a bit. So in the last couple of iterations here with Hadoop, it was probably one of the first technologies that really was born in open source in the sense that the first vendors out there to produce to field a product that was deployed widely, they were largely open source vendors and later became OpenCore vendors. So sometimes it takes a while, but in general, this is definitely the way things are going. And these are big waves that are being generated. So Spark was a big wave that Cloudera sort of latched onto. Over 1,000 contributors. Last time I saw a survey, which was in 2016 from Databricks. Similarly, now we've got Kubernetes, project led by Google. It's got around the same number of contributors with over 10 commits, so significant contributors in 2018. So there's large waves of innovation happening, and of course every person day, person month, person year that's spent on these projects is effectively time that's not spent building proprietary products for vendors out there. So if you think about it that way, it kind of makes a lot of sense to latch on to that wave if you're a user or a vendor, because you're getting technology that's moving and improving faster than anything else. You're getting a lot of leverage out there, and we'll talk about the leverage. This is big business, so open source services is predicted to be $33 billion in annual revenue over the next 5 years, so actually 2017 to 2022, so next 4 years now, at a 23% average growth rate per year, compound annual growth rate. So that's very, very significant. And that's actually just the services part. So services is defined as training, consulting, and subscription support and maintenance of open source. So if you have a company that's distributing and providing bug fixes and other improvements, minor patches to the source, but not products that consume open source. That's actually much, much, much larger. So if you look at the data management space, overall though, actually that's not peanuts, but it's quite a bit less than the overall data management market. Data warehouse alone is about 20 billion of that, so you're talking about $105 billion by 2020. So the product business in a lot of cases is actually larger than the services business, although the services business is pretty big. On a pure play perspective, it might have gotten a lot smaller in the last week with the announcement by IBM and Red Hat, and I'm sure some of you guys followed, some of you folks followed. So that's actually the commit stream for Kubernetes. You can see rapidly ramping up and then stabilizing over about the last year or so. We've reached a state of ubiquity, I would say more or less within the global 2000s. So the question is not why open source, it's more like why not open source? Because again, as a CIO or a VP of IT somewhere, you would be foolish not to follow the innovation to remain competitive. Again, these open source based products and technologies are getting better at a faster rate than the proprietary products by and large, right? So you're leveraging that work both as a vendor and as a user of the technology. So hence, it's pretty much everywhere you look these days. Okay, in addition to that, the great cloud reset, which is the opportunity to reconsider your technology choices as a user when you migrate data and workloads and applications to the cloud, is just accelerating that, right? Because it's a good opportunity to look again at what's out there and how you would build the next application in a cloud native way, leveraging some new technologies which are more likely to be open source. But there's also consolidation of open source vendors and some waning tides of projects that are getting less contributions, right? So you have the acquisition of MuleSoft by Salesforce earlier this year. You have Cloudera and Hortonworks coming together. So we've announced our intention to merge a few weeks ago. And you also have the acquisition of Red Hat by IBM, which is the largest acquisition in IBM's history, a couple of days ago with $34 billion. So, and they're the largest, by the way, purely open source company out there in the world. And you have projects that just have waning participation. So that's the commits of Docker over the last couple of years. So there's the peak around 2015, 2016, right? So these things do subside over time. There is consolidation over time. The IBM Red Hat in particular is kind of interesting to track. IBM, we're still committed to open source, blah, blah, blah. We're still committed to open source, blah, 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 trust us. And then Red Hat, I thought, made an interesting observation saying that, really open source is the basis for digital transformation. So every large company is talking about how all of their business processes are going to be redesigned as they go digital, as they transform, become digital, totally digital-driven company. To me, that sounds like a word from the 80s. But in any case, that's the word that all the big 5 consulting firms are using as they're pitching their transformation packages to CIOs. So, we're committed. We're still preserving our commitment to open source. We'll see how that actually plays out. I think that that's true to a large extent, but it's true in the sense that their technologies, Red Hat's technologies, are in the later stages of the innovation cycle. So most of this talk is going to be kind of talking about that innovation cycle and what does it look like. By the way, my timer is still at 45 minutes, so I won't take another 45 minutes. So we'll just have to wing that. Okay, so let's look at some evolutionary models for OpenCore. So how do both users and vendors of technology evolve in such a way that kind of drives this natural inclination to open core products. So in the beginning, it's all about expertise. It's super important to have very, very special people who are very, very rare and unique to participate, either as a user or a vendor. So this is a picture of a team of rocket scientists that the US was recruiting in a secret operation called Operation Paperclip back in the 1940s and 50s, and they were basically trying to compete with Soviet efforts in rocket technology, and so they were just recruiting the heck out of engineers and really doing everything they could to get their hands on a very, very small number of people in the world that understood anything about this, because it was considered an existential threat, and it was extremely important to have that knowledge and that scientific capability to those countries. And so, having just 1 or 2 people on your team in the very, very early stages of one of these innovation cycles is really important if you're a VC investing in a company, or even if you're a consumer of the technology. So you hear about these wild salaries and incredible retention bonuses and things that were paid to data scientists in the early years of, let's say, the big data wave. It's all about that very, very rare expertise and doing everything you can to get your hands on that expertise and leverage that to move your competitive advantage as a consumer or as a vendor in the space. So if you're a vendor, it's all about expertise in the beginning, and how can you leverage that expertise? Well, there's a couple of very simple ways you can do that. You can start a trading company, which, by the way, is how Cloudera started. It's the cheapest business model to bootstrap. It doesn't really take any capital. It builds your street cred. There's not really any product strategy required to do that, and that's consequently why a lot of big data companies actually started in the training business. And it's really when the early market is these very, very sophisticated early adopters, that's actually what they need the most and are asking for the most. So it makes a lot of sense. And the next thing you can do is, of course, do services, do consulting. So you can build applications for people. And some of that work in the early days is just dealing with the notoriously rough edges of the technology. So if you've ever tried, Hadoop in 2009 or 10, it was a really terrible experience to just install it, let alone debug it, maybe use some APIs that would break in the next release. And so you can make a lot of money as a company trying to be in this ecosystem, just smoothing out the rough edges, or helping the very small number of people who know this technology deploy something that actually get it into production. Then the next thing you can do, which is a higher leverage business model and more scalable, is to offer support, right? Your employees don't have to travel. They can answer a lot of the same questions, again, very quickly. They can provide a knowledge base. It's just a lot more repeatable business with higher margins potentially. It requires that you have a reputation, so you be someone worth paying for support. So you need to be able to solve a problem when an incident is raised much more quickly than your customers, which is actually hard in the early market in some ways because you have a very sophisticated set of early adopter customers to work with. They might be as knowledgeable about the source code as you. They might be committers on the project. They might be able to go in the code and make the change themselves. So you really have to be ahead of the game with your expertise. Again, it's all about expertise. But that actually fits what the early market customer wants, and we'll talk about that in a second. So the next thing you can do, kind of in the next phase, the second phase of the life cycle, is actually just build a better mousetrap. So actually build a better product and also provide insurance. I'll talk about what that means. So OpenCore Free is kind of the next model, which is we have an OpenCore product. It's based on an open source project or a collection of open source projects, but it's got proprietary features around the edges. The next thing you could do is have a freemium model where you have a free edition and a paid edition with some proprietary and paid-only features. And then the next level of evolution is you can have basically just a paid proprietary product which has open source software inside. And in some ways, this is the best of both worlds. If you're selling to large companies that are very risk averse and they're used to getting insurance, in other words, they're used to getting indemnification from their vendors. So in other words, someone to point the finger to and not get fired if you adopt the technology. And actually beyond that, there's actually legal limitation of liability that we provide to our customers. So if they launch a service or product based on our product, then they can't be blamed completely for it, completely crashing and burning and melting down your data center. And of course, that liability goes to us. And of course, we very carefully limit our liability to a certain amount of money so that nobody's at the end completely liable. But the point is that a lot of our customers are really looking for something that feels like classic commercial software, but of course has the benefits of these newer technologies which are developed in open source under the covers. So similarly, the users of open source or consumers of the technology, the end customers, move through a similar kind of maturity model over time as this software gets developed. And early on, it's the innovators who are actually the ones building the stack themselves and heavily modifying it. So in our case, Hadoop was invented at Yahoo, and they continue to work on the technology, but Facebook, Twitter, Quantcast, a number of other customers made heavyweight modifications to the stack, building their own projects on top, building their own file formats, making major changes to the way it functions. And they did so because they had to. No one else provided a data analytics stack at that scale that could serve their needs. No one could index the web fast enough, so Google had to build a system, and the same for Yahoo. And no one could build a system for SQL analysts to look at data at the scale Facebook was collecting, and Twitter and others. So they had to build these systems, but often in the long term to their detriment, because it actually paints you in a pretty tight corner and causes you a very, very heavy maintenance burden later in the cycle, and later in their cycle, when they weren't relying on having those people like in Operation Paperclip, the top 50 engineers, the top 100 engineers in the world on staff, and they didn't have any more stock options to give them, and the incentives weren't the same as they were earlier on in the process. Now they have a very, very brittle custom-made system that no one else uses effectively that they have to maintain for decades to come. And then you have the purists, so they actually maintain the stack. In other words, they're able to make patches themselves and contribute patches to the open source project. They understand it inside and out, but they're not making major modifications to the way it works. They hate vendor lock-in, therefore they don't want to pay for support. They don't want any proprietary line of code to taint their deployment, and they think it absolutely stinks. But they spend it all in human capital, so they'll spend a lot more with the engineers they have to have on staff to maintain that code base in a very, it's very exotic technology still. So there's some companies that are sort of still in this stage of evolution when it comes to big data. Then as you move into the enterprise, you move away from the, let's say in this case, the data-driven companies, the web properties, the early adopters, into other industries in finance and telco and retail and healthcare and so forth. You encounter the emerging advanced technology groups within their IT organizations. And these are the scouts. So these are people that are trying to look at the latest technology and do a POC or do a pilot project to establish the level of risk to introduce that technology into the broader IT organization. And you have to be able to cater to these folks. They have smaller budgets. They have maybe some exotic requirements that maybe your other customers don't have. And so you can end up designing away your budget for a few specific customers, and you have to be careful about what the broader market is going to want. And then the rest of the people are the majority, or the lemmings, whatever you want to call them. If you don't know what that is, that's a animal that commits suicide en masse just because one animal follows all the rest of them off the edge of a cliff. So that's a little bit of a joke there. But basically it's the masses, the hordes of IT practitioners. They don't participate in the community directly. They just say, fix it, Mr. Vendor. It's your software. They want the indemnity. Of course, once you reach this stage, you really need to have committers on the project. You really need to be in control of the project largely, so that you can actually get that bug fixed, because getting that bug fixed means having the rights to push some changes into the repository and get it merged. Otherwise, it becomes a mess of branches all over the place. So when you get to that stage, you really need to be in control, because the customer doesn't want to and doesn't have the ability to really participate. So getting into a little bit of the mechanics of what the participation looks like and packaging and licensing considerations when you're assembling OpenCore, that's interesting. Let's go back a little bit. The first thing is, of course, you need critical mass of vendors. So one vendor does not make a community. Otherwise, savvy customers will see right through that and say, hey, this isn't really a community. This is really you, saying that you're open source, but really there's not optionality, right? I really don't have the option to go to your competitor if something goes wrong and you're still an early stage company and I can't bet my entire business on you. So there need to be multiple vendors early in the game, because the vendors will typically be small, and something that a Global 2000 doesn't want to really bet their business on, unless they maybe invest in the company, buy the company. But they don't really want to be software companies, most of these banks and telcos and so forth. And so there needs to be critical mass, and this was completely true of Cloudera and others early in the game, to create a community and to create that optionality for the buyer that will give them the confidence to go ahead and adopt open source fairly early. So committership is, of course, the ability for a user to or a engineer to actually push code into the main trunk of the project. And that is a rigorous process. It can take a year or two even to become a committer. It's very critical, if you're a vendor, to get as many of these people on staff as possible. You either hire them, you acqui-hire them, or you groom them and invest a lot to grow them into being committers. And it's very coveted, and it can be actually political as there becomes more and more money in the game. Sometimes companies can block other companies from becoming committers. They're not supposed to, because those are not the rules of the process, but often things do become political and not fully based on merit, like the open source community would lead you to believe is the game. You can certainly use substitutes. So you could be a committer on one project, but your day job is working on another project. And if someone needs to commit code, because they're focused on this feature, they can give the committer the code and have them do it for them, because they have the credentials, they have the keys to do this, they have the reputation. So that happens actually a fair amount, but you don't want to rely on that completely because that's kind of dysfunctional. You'd like the engineering investments that you make to be kind of focused on delivering that capability so you can better manage your business. And then releases are interesting. You'd think they'd always be driven by technical considerations. Well, we're going to do a major re-architecture of the SQL engine here, or we're changing the protocol completely here, so it's going to be a backwards incompatible change. But actually, sometimes that's not true. Sometimes it's just driven by the vendor wanting to look mature and grown up and saying, this is a 1.0, yay, or we have a big conference coming up, and this is a 1.0. This actually happened with Hadoop back in 2011 or so, where it was like 0.2, 0.2, 0.2, and then 0.21 was never used, and then all of a sudden it was 1.0, right? And then less than a year later, it was 2.0. And you got to wonder, what's going on there. But you do need to keep track of the open source release process, or what we call the upstream release process. So upstream is everything that's going on in the cross-vendor community or the independent contributors. Downstream is what's going on in your company and the product you build and ship. And so you need to plan ahead your release cycle to be in line as much as possible with the with the open source release cycle, if this means maybe there's backwards incompatible changes. So you don't want your 2.1 to embed a 3.0 that has backwards incompatible changes, because now your 2.1 is incompatible from your 2.0, and you really intended this to be a minor release. So you have to look far ahead. Okay, like what is the release cycle of this component? And if you have a whole bunch of components that you're bundling together into a suite, obviously that becomes more and more complicated. So that's really something you have to think about, and then try to drive the community as much as you can in the direction that you want. Let's make this thing compatible by having negotiation of 2 different protocols, for example. And then some other things that are good hygiene in terms of participation are actually committing all your code upstream first and then consuming it into your own product. So in other words, if you have a patch that you need to make to fix a bug or improve something, you'll create a ticket upstream and you'll say, I'm proposing this change. You'll write the code, you'll write some tests, you'll push that code in, you'll have it go through the cycle of automated testing and someone giving it a +1, and then going into the build, and then you'll pull that back into your code base that you ship in your product. And the good etiquette says you always do it that way, as opposed to, I'm a participant in this project, but actually I'm just pushing all this stuff into my product, and it's not available to the other vendors, right? It's not available to the other users. That's bad karma within the community. But you got to remember who pays the bills, which are these big customers, and they want their fix now because they have a production down issue. So you need to be able to patch your product independently of the open source project as well in emergencies, so that you can send customers that fix faster than going through the cycle of that change in the open source community. So there's nothing wrong with doing that as long as you immediately or very shortly after publish the code that you create associated with that project. And of course, this is completely different for proprietary features, but if it's really core to the open source component, that's kind of what's expected of you as a vendor. And then you can expect that it's going to take months and months for certain features to get in code reviews, design reviews. Sometimes this is based on political things like people stalling in the community because they don't want you to get in your feature because they're a competitor, or it could just be that they're not focused on that area anymore, or it could be because you're a newbie. It takes months and months of investment for new engineers doing this kinds of work, even if it's not related to their feature as well, to become committers. So you have to build that into kind of your model if you're going to do this. Packaging and licensing, early on I would say it's kind of the Big Mac approach. You're kind of taking the meat and making the burger, if you will, by throwing in a bunch of additional condiments, so additional patches, an installer, and hey, it's compiled so you don't have to go to the source code and compile it for your platform. That's one approach to packaging in the early days of an ecosystem, but then as there become more and more related projects in the ecosystem, in the beginning there was just HDFS and MapReduce in Hadoop, and there was the Hadoop project, it was one Apache project. Then you have multiple projects that are related. They help you to do SQL on Hadoop or to have an operational database, a key value store in Hadoop. They're all related though, and they're useful together. There's Hive for tracking metadata and so forth and doing SQL on Hadoop. There's all these projects, and you have a happy meal where you bundle all of these projects together. You do some cross-component tests. You provide some additional tooling, not even getting into the proprietary features, but there's a whole lot of value to be created there just in that cross-component testing, making sure that everything works together. And I'll talk a little bit more about that. If you're packaging a whole bunch of open source projects into an OpenCore product, check the licensing. Apache license and BSD and a bunch of others are pretty permissible for making composite products, but GPL and LGPL, it depends. So, LGPL, if you don't modify it, you have to really prove that you haven't modified. You have to put the right license, text inside the product, and GPL you can't really do if you don't want it to change the license characteristics of the overall product. So you really have to work with the lawyers and understand that. It's certainly fine to take an open source component and wrap it with some additional value that you add on top and drive its use or its availability with some license key entitlements. There's nothing wrong with doing that as long as you add some value. Be careful what decisions you make early on, because you may want to evolve your licensing scheme later, and once you've got a lot of built-in expectations of a large user base, it's going to be difficult to change that. So there may be competitive pressure to give away something for free early on because there's just so many entrants in the space and there's such fierce competition, and really you're adding a lot of value and you're giving a lot of value away, and you're setting a lot of expectations about what should be free and what not should be free, and that's important to think long-term about, so play chess when it comes to that. In terms of strategy, I talked a little bit about how vendors tend to evolve from the services business into the product business over time. But some general notes, catch waves of innovation early, so try to jump on new projects that may be even seen initially as competitive to your product, because there's so much momentum behind them and they are going to drive a lot of customer value. And if you can help shape the trajectory of that project and make it fit better into your product strategy, over time, it'll be to your tremendous advantage. Spark is an example where I think Cloudera did a really great job, and now we have things like Kubernetes where there's a huge wave of innovation. Keep people who are really smart about this in your office of the CTO looking for those things, always out ahead, looking years ahead for those things. Get ubiquity by making your product free initially in the early market. That's obviously going to drive adoption, and we call it implicit escrow. So with proprietary software, you have this agreement a lot of times that says, if the company goes bankrupt, we put the source code over here in escrow with somebody else and they'll give it to you, so you're not taking a huge risk by working with this company. That's not true in the open source world, which is great. So use that point to your advantage. Say, hey, if I go out of business, no problem. You've got all the code there in Apache. By the way, the cloud is actually the biggest example of vendor lock-in that ever existed, but a lot of folks are not necessarily inherently conscious of that as they go charging forth and consuming all these cloud services, which is, again, why we think multi-cloud is important. Start by sanding the edges, streamlining consumption, making it easier to install and deploy and debug. Just make it easy to consume, right? And people will consume more software, bundling projects together. Cross-component testing, but be a platform. Don't make things incompatible. Make sure the file formats work with all the different engines that you have and all the different storage systems that you have. Make sure the APIs remain stable. Have some reasonable standard for not making backwards incompatible changes. Protocol negotiation is really useful. So if you're doing a rolling upgrade and you want zero downtime, some of the machines have to be an older version while some of the machines are a newer version for a short period of time. They need to be able to talk to each other, or you can't do upgrades without downtime. Make the simple things like the ports consistent, right? The configuration, the user experience as much as possible. If you bundle a bunch of projects, that's hard if they all have different UI designers and UX people that worked on them, but try to do the best you can by layering something on top that provides a common user experience, and also a single upgrade workflow for the entire thing. Like, that's really useful that I can schedule one maintenance window, have one downtime or no downtime on the weekend, and upgrade 10 different things that 20 different teams are using. That's being a platform, right? So don't just throw a bunch of stuff in the box that doesn't really work well together, is going to break next release, because you won't have long-term adoption and expansion. So once you've done that, you can differentiate by sponsoring your own projects. So we actually sponsored a project that we developed internally to get some competitive advantage that was kind of an alternative to what other vendors had, and then we made it open source, got some additional lift from some additional contributions, and we showed leadership in the space, and we differentiated our product, right? But we did so with some competitive advantage by developing it initially internally. But we had the credibility at that point to then go and say, okay, this is a new Apache project, and everyone knew we weren't just talking about an empty GitHub somewhere. Eliminate all the reasons for people to say no. So the mainstream, more conservative, late adopters, they fear project failure, right? So test, 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 and be a throat to choke, as they say. So be the person that they can call up and blame if something goes wrong, that they can call up for support and have that security of having someone that's going to support them. They fear compliance violations, so have governance features, like we'll talk about this too on the next slide. And they fear data breaches, right? So have really, really strong security features. So make sure that whether these are open source or not, that these features exist in the platform, because if you do have an open core, then these are the things that are going to mitigate the fears and the risk in the minds of the mainstream buyer later on in the innovation cycle. So what should be free and what should not be free? Well, here's some basic guidance. You lean free when a feature is basic or mandatory for the system to work. You lean free when it needs to be compatible across multiple vendors. You want people to be able to migrate to your platform from the other vendor. Now, of course, the downside is they can migrate away from you to the other person if it's compatible, right? But in general, you benefit more by having compatibility across vendors. That gives the customers much more comfort in deploying this heavily. Again, if you do a better job and you provide a better mousetrap, people will migrate over to your platform more, and it'll be easier and seamless for them to do so if you make that a free feature. You make that an open source feature, even better. And then you can lean paid when it's about the productivity of the user or the admin, just boosting their productivity. So we have data discovery tools in our SQL interface to help find the right table, suggest the right joins, for example, reorder the joins, data that might be useful to you, how you should optimize the data model and put foreign keys over here, things like that. You know, or administrators, you know, be able to roll back to the configuration from 3 weeks ago, do rolling restarts, all those kinds of things. They're not mandatory, but they boost productivity for the user. It's easier to set up encryption. Features that are really to what we call CYA, they're really to prevent risk for the operator. The types of things I mentioned before, like governance and security features. So you can also look in what is traditional software, so closed source software, on-premises enterprise software tout as high-value features. And these are the things that people are willing to pay a lot of money for. So I already mentioned administration, but you know, high-end security, governance, also workload management, particularly in enterprise data warehousing. When there's a whole bunch of different competing queries that are running at the same time, some are really short-running, some are really long-running, some are scanning massive amounts of data and doing roll-ups, some are just retrieving a small amount of data. If you can schedule all of those things efficiently, you get a high degree of utilization and a high degree of quality of service and consistent query times, people will pay a lot of money for that kind of feature. So an example for us is we added some features around HDFS encryption. So there was a capability in the platform already, but adding an extension point or a plugin system so that you can develop a proprietary implementation easily and other vendors can do the same, but there's also a baseline reference implementation in the open source version is a really, really good strategy. So you can define encryption zones in HDFS. These folders are encrypted with this key and these with that key, but the thing that stores the keys is just a little folder inside the JVM, right? This is not a super secure thing, right? So what we did is we bought a company that actually does enterprise key management, right? So you have specialized hardware where the keys actually get stored. You have a server component for managing access to the keys and a vault for that. And there's a whole bunch of IP just around the key management aspect of it. And by the way, you can tell the customer it's not just the HDFS data, it's all the local volumes on all the machines, all Linux. There's not a byte of data that's unencrypted because I also have for you Linux encryption. Thank you very much. And so they can check that box. Yes, encryption at rest, even though some of it has nothing to do with the actual open source product. So looking like legacy, Be a willing throat to choke. I mentioned this already. Give the customers that insurance policy, that indemnification that they're looking for. Hire a traditional enterprise sales force, because traditional enterprise customers speak traditional enterprise. They don't speak cloud open source. They also don't speak consumer. So that's important to know in terms of who you have and what their behaviors are to go out and sell these big deals. Play to the analysts, industry analysts. So, you know, there's all these Magic Quadrant reports and all these categories, Forrester Wave, things like that. You really want to ideally have your product mapped to one of those categories. You can create a new category, and that is helpful if you're disruptive enough, if they can follow you. But a lot of times, you can actually make more money by going after those categories and say, yeah, actually what we sell is actually a data warehouse. You know, we'll participate in this $20 billion market. Yes, thank you very much. In addition to, you know, the Hadoop market, if you will. And then even just hide the OpenCore if it helps, right? So if you now have a system that's stable enough, reliable enough, supports enough concurrent users and workloads that and has the security features that it feels like an enterprise data warehouse, well, just go sell it as an enterprise data warehouse, right? You can still sell it for pennies on the dollar compared to Teradata or Netezza and make good money, and don't even necessarily talk about the fact that, yeah, there's actually open source components inside there, right? So now it's just our data warehouse SKU, our data warehouse product, right? There will be what we call co-opetition, so this is collaboration and competition, mix of the two that obviously will happen in any of these ecosystems. You can, of course, collaborate with your competitors. You know, we would go to meetups with Hortonworks all the time. We'd work with them on features. We'd be commenting and reviewing each other's code. And it's really mandatory at the core to have that critical mass of vendors collaborating on the core, to have enough vendors for there to be credibility for the buyer and to maintain compatibility. But call them out if they misbehave, because there are cases where you can be active in a community and because of politics, they'll be refusing to review your code or look at your design docs or your proposals, or reject an extension point because they have something proprietary that they don't want to allow you to offer better implementation of, which is really bad. It really should be extensible in most cases, or just they'll just stall on committing your code. Making basic functionality proprietary, so you know, a client in a particular language or a REST interface, something like that. I've seen cases of this where vendors have offered that as proprietary, or they're doing faux open source where they just post it on a GitHub and don't actually facilitate any participation. So yeah, the code's out there, but they just take the code, add some more, and then they ship a product on top of that. So how, like, what's the process by which some other user could get something in and get it reviewed, and then has it come back to them? It's just on a GitHub, or it's an empty project that doesn't have much value in it. That can happen as well. So what you don't do is you don't ship crap. So you don't take all the low quality code, features that don't actually work, features that haven't been battle tested, and give them to the Global 2000 companies and say, yeah, put this into production. Or take a project that doesn't have much in it and say, yeah, this is my new project, it's really great at doing this, but actually it's a roadmap, right? It doesn't really do much yet. It's still going to be a year before it does anything. So don't hesitate to turn off, undocument, or just say these features are unsupported, these capabilities are unsupported, because they're not ready, right? There may be 1,000 connectors out there, but if only 20 of them are really battle tested and ready to deploy, don't say you support the 1,000. You don't have the expertise, the code's not very good, customer's not going to be able to rely on it, you'll lose reputation. Don't oversell your capabilities and say, oh, this is the new platform for everything, for example, in the case of Hadoop or in the case of Kafka. Can it really do all those things really, really well, one instance of it? I'm not so sure that I would recommend customers to do that. And then also don't sink in a huge cost where it doesn't add value. So in some cases, it might be useful to partner with another company to field your product if you need to play catch up on expertise. So it's very, very early stage and you actually don't have the committers, you don't have the engineers on staff, you can acquire them, or you can partner with a company to provide some support to fill in that gap, or maybe there's some plumbing within the product that you need in order to run the product. I mean, we don't maintain Linux committers at Cloudera, for example. There's other examples of this where it might make more sense to actually partner with a company, have a contract with them to do maintenance of the technologies, particularly below your stack, where they can actually fix bugs for you. So Oracle could fix a bug in Java, you know, better than we can by staffing up a whole Java group at Cloudera. It's a good example of that. So I know I'm over time, so one more slide, which is what happens as these ecosystems mature and these technologies mature. One thing that can happen is the freedom that comes with open source naturally, and also the excess VC money that gets flushed into the market can lead to a whole bunch of wasteful project proliferation that's not efficient for the market over time. So, competing features that do the same thing, or competing Apache projects that do the same or similar things, all these different data flow engines that exist in the Hadoop ecosystem. At the end of the day, this isn't useful in the end game, in the limit. And so later on in the innovation cycle, you get diminishing participation in the project itself, and so there's diminishing leverage for new vendors to come in. Of course, if there's a whole bunch of activity, a whole bunch of development and innovation going on, it makes sense for a vendor to jump on that and start basing their product based on that. Later on, it diminishes, and also diminishing differentiation means it's less beneficial to the market, to the users, for there to be competition, right? So the actual friction of the competition and these competing features actually makes it no longer worth it, and the market will decide when that becomes the case, right? When there's less and less differentiation and contribution, then mathematically it just makes a whole lot more sense for there to be consolidation and for the open core to remain inside, but it not to be sort of the thing that companies differentiate on. And so the arena of competition and value creation just moves elsewhere when you get to this stage of the game, right? So you can compete with different types of vendors. They don't do the same exact open source thing that you do, but maybe they do something similar in the closed source world. The enterprise data warehouse is an example that I mentioned before, or it's about having a PaaS offering, for example, or it's about having hybrid cloud and multi-cloud capability to deploy that technology in a fluid way across different domains, public cloud, private cloud, bare metal, hybrid cloud, and so forth, right? So that's where you can add value then, by giving customers that portability, relieving them of the lock-in, for example, or just competing with another type of solution that's not open source. So then the open source vendors consolidate over time. Okay, 1 minute for any questions, perhaps? Nope. Okay. Should I go ahead?
We've got time for one question, and then we have to set up for the panel.
One, okay.
You should take the top one. It's the most popular.
I like that first one. Don't you think we've deviated far from the idealistic ideas of Richard Stallman? He's the free software guy, right? Free as in beer. Around free software, do you think it fundamentally changes if open source is just a for-profit business strategy? I think we haven't deviated from that per se, and that it still exists. But I think it's a function of market dynamics, right? In each particular case. So I think that there's a lot more free software out there today than there used to be, and there's a lot more that you can get. I mean, think of just what you get as a consumer for free these days. That's either advertising driven or funded by some silly VC money. But I think that it doesn't just become a for-profit business strategy. I think that it becomes a strategy for efficiency. So you have more organizations, more developers contributing on the same project. You actually do get lift out of that. You get economic value, which drives down the cost for the ultimate consumer of the software. And I think we are still all benefiting from that substantially. It's just that these things go in cycles based on the incentive structures, which is kind of what I tried to talk about there in my talk. So I think that it still does good things for the world, even if it's not, even if the purists may complain that it's no longer it's complete free for all.
Thank you very much to Matthew.